This instructional video is about dividing polynomials. And this time it is about using synthetic division. Yeah, synthetic division. Okay? Now, when we, on the last instructional video, we talked about dividing polynomials. We used a long division. And when we did do a long division to find the factor of a polynomial, we realized what is called the remainder theorem. Remainder theorem. And let me explain what that was. If we had a polynomial, if a polynomial that we recognize as being f of x, if that is divided by a binomial, let's call it x minus k. K is the constant of a binomial term, okay? Then we realized the remainder is, well, given as the r, f of k. And what that will give you is the actual factor. And so what that means is we have to, whatever the term of a binomial we get, we have to take the inverse. And we're going to use the inverse of the term of the binomial and use it in our synthetic division. Whew, that was a mouthful, huh? But let me show you how that works. So first, what we do is we take our polynomial, in this case x to the third plus 2x squared minus 6x minus 9, okay? And we're going to divide that by x minus 2. And k is the inverse of that, so it's going to become actually positive 2. And we're going to take the coefficients only from the polynomial 1x cubed plus 2x squared minus 6x, and the last constant, negative 9. Watch this now. And we're going to use a synthetic division written this way. In fact, in some European countries, they do the division this way. And we're going to take that k over here. And here's how it works. We're going to take that leading coefficient and we're going to bring it down to start things up. And what we'll do is take that 2, which is the k, multiply it to the first coefficient, and get a 2. 2 times 1 is 2. And then we're going to take the second coefficient and combine that to become 4. And then we're going to take that k again, multiply to that one to get 8. And then we're going to combine negative 6 and 8 together to get positive 2. And then finally we're going to take that k and multiply to that 2 to get 4. And when you take the difference of those numbers, we get a negative 5. And that happens to be the remainder. And so finally the answer becomes, in this case, well, what is the quotient between this polynomial and this binomial x minus 2? Well, that's going to be written as 1x squared plus 4x plus the constant 2 now minus 5 over the binomial, which is the inverse of the 2, given as the original x minus 2. Maybe this will make better sense. Let's take that same polynomial and take the the coefficients again, the 1, the 2, negative 6, and negative 9. And we're going to use a synthetic division again, but this time let's divide it by x plus 3. And again, we're going to take just the k. K is the 3, but it's going to be the inverse, so minus 3. And we're going to use that now, that k, to find the factor, the quotient that is. So bring down the 1, 1. Negative 3 times 1, negative 3. 2 and negative 3, combine them, negative 1. Negative 3 times negative 1, positive 3. Combine those two terms, negative 3. Finally, the k, negative 3 times the difference here, negative 3. Negative 3 times negative 3 is positive 9. Check this one out, huh? Negative 9 and 9, of course, 0. Now, this one's a remainder. Now, you would think we're done, but I want to make you aware of something. You see, when we end up with the remainder for the quotient, we actually end up with a thing called the factor theorem. And what that says, if you have a polynomial, or a polynomial that is named a function of x, it has a factor x minus k if and only if the f of that k, if we stick that -3 into that k, gives you a 0, then it has a factor of, that is the factor. In this case, this is the factor because our remainder came out to be a 0. And that's what the factor theorem says. You're probably thinking, well, we just saw that. Exactly. So what's the answer? The answer is, okay, x squared minus x minus the 3. And that is defined by the factor theorem. Oh. Now that being said, why don't you try this guy? Divide that polynomial by that binomial. All right. How'd that turn out, huh? Well, let's see how it goes. Here we go. So now you said, all right, I remember. All I'm going to do is first identify my k. K is the inverse of the binomial x minus 3, the constant. So it's going to be the 3. And then I'm going to list all the coefficients. But first, are they in sequential order? x4, x3, x2, x1, and a constant? Yeah. So here we go. First, the 2, and then -6, and then 1, and then -3, and then finally the constant -3. Okay, and then we're going to divide that using the synthetic division with the k outside, which is the inverse of the given binomial factor x minus 3, just the constant 3. So just like before, over here, bring down the leading coefficient to start things up. In this case, it is 2. So 3 times 2 is going to be 6. Whoa! From the get-go, it cancels out, zeroes out. Now here's how this works. Now 3 times a 0 is a 0. Combine that, we get a 1. 3 times 1 is 3. We get a 0. And 3 times 0 is 0. -3. Uh-oh. So we have a remainder of 3, or negative. So how do we find that answer? How do we write that? We're going to write it this way. Okay? We're going to say 2x to the third, because the highest degree was a fourth. Next one's going to be 3, plus 0x squared plus x plus 0 minus 3 over x minus 3. Or let's simplify, get rid of this guy, so it's 2x cubed plus x minus 3 over x minus 3. That wasn't too satisfying. Well, that's the way sometimes the life goes, huh?